Welcome. Tonight, I invite you to set aside the weight of the day and join me on a quiet journey through the vast reaches of time and space. As you settle into your blankets, let the world outside your window fade away. The sounds of the modern world, the hum of electricity, the distant traffic, the ticking of clocks, all of it begins to soften, replaced by a profound and ancient stillness. Imagine, if you can, the room around you dissolving into a soft, dark velvet, leaving only the gentle rhythm of your breathing as we prepare to look back, far beyond the horizon of human memory. Before we descend into the deep history of our cosmic home, if you find these moments of silence and discovery comforting, I invite you to gently subscribe and like this video. It is a quiet way to ensure we can continue these journeys together, and I would be honored to have you join our community of night travelers. But for now, simply let your eyes grow heavy and your mind become. We are traveling back to a time before the Earth existed, before the sun was born, and before the light of our stars reached this corner of the galaxy. It is a time frame so vast, it is difficult for the human mind to truly hold. Our solar system is roughly 4.6 billion years old. To put that into perspective, if the entire history of our system were compressed into a single calendar year, a human life would last for only a fraction of a second, flickering like a tiny spark in an endless night. In this immense span of time, our world has seen the rise and fall of mountains, the birth of oceans, and the slow, steady dance of the planets. But at the very beginning, there was no solid ground to stand on. There was no warmth. There was only a silent, cold cloud of gas and dust drifting through the void of the Milky Way. This cloud, which scientists call the pre-solar nebula, was a cradle of potential, waiting in the dark for billions of years. It was a place of perfect equilibrium where nothing moved and nothing changed. As we leave the comfort of the present moment, we must let go of the familiar. We are moving away from the bright, busy world of today and sinking back into that original silence. The air around you grows cool and still. The light fades into a deep, restful indigo. We are standing at the very edge of creation, looking into a cloud that holds the atoms of everything you have ever known, the iron in your blood, the oxygen you breathe, and the very dust beneath your feet. It is all there, scattered and thin, waiting for the first breath of gravity to wake it from its slumber. We are going back to the beginning, back to the cold, quiet heart of the nebula. Imagine yourself floating in the center of this immense cloud. It is so vast that it would take light years to travel from one side to the other. This is the pre-solar nebula, a giant molecular cloud, and it is the quietest place imaginable. There is no wind here, no sound, and no light. It is a realm of absolute tranquility, a place where time seems to have no meaning. Despite its size, this cloud is ghost-like and ethereal. If you were to look around, you wouldn't see thick smoke or heavy fog. Instead, you would see a darkness so pure it feels like a soft weight against your eyes. This is because the cloud is incredibly sparse. In a single cubic centimeter of space, about the size of a sugar cube, There are fewer atoms than you would find in the most sophisticated vacuum chamber ever built by humans. It is more nothing than something, yet within this vast, thin nothingness lies the blueprint for everything. The atoms that do exist here are the simplest building blocks of the universe. About 3/4 of the cloud's mass is hydrogen, the very first element ever created. Almost all the rest is helium. These two gases, light and invisible, drifted together in the cold, held by the most delicate of gravitational threads. There are also tiny microscopic grains of dust, frozen water, carbon, and silicates floating like silver dust in a dark room. They are the remnants of stars that lived and died long before our own, waiting to be recycled into something new. The temperature here is unimaginable. It is just a few degrees above absolute zero, the point where all motion nearly stops. In this freezing cradle, the molecules move with a slow, heavy lethargy. They have stayed this way for millions of years, a frozen snapshot of time, balanced perfectly between the desire to expand and the quiet, internal pull to come together. It is a state of perfect frigid grace. But this perfect stillness was eventually destined to break. Somewhere in the distance, far across the local neighborhood of our galaxy, a massive star reached the end of its life. It ended with a magnificent bloom of energy, a supernova. The light from this event would have been brilliant, but it was the invisible shockwave that followed which changed the course of our history. Think of a still pond, its surface like a mirror. If you drop a tiny pebble into the water far from the shore, you see a ripple begin to travel outward. It moves slowly, almost imperceptibly, but it carries energy with it. The shock wave from that distant star was like that ripple. It traveled through the void for centuries, until it finally reached the edges of our quiet cloud. As the ripple passed through the nebula, the silence didn't break, but it shifted. The atoms were nudged. The dust grains were pushed just a fraction closer to one another. The equilibrium that had lasted for eons was tilted. The stillness began to move, not with a rush, but with the first faint heartbeat of a new beginning. The cloud was no longer just drifting. It was starting to feel the first stirrings of a power that would eventually craft the sun and every world that circles it. The long sleep of the nebula was coming to an end. In the quiet wake of that distant shock wave, a new force began to assert its patient authority. This is gravity. It is a curious thing. Scientists recognize gravity as the weakest of the four fundamental forces of nature. A simple, tiny refrigerator magnet has enough strength to defy the gravitational pull of the entire planet Earth just to hold a photograph in place. And yet, gravity possesses a quality the other forces do not. It works over the greatest distances imaginable, and it never, ever tires. It is the long-reaching hand of the universe, and it was now reaching for the atoms of our cloud. As the atoms of hydrogen and the specks of ancient dust were nudged just a fraction closer together by the supernova's ripple, their collective mass created a tiny bit more pull. Like a soft, invisible blanket being tucked in at the corners, the cloud began to collapse toward its own center. It wasn't a sudden fall, but a slow, graceful contraction that would last for hundreds of thousands of years. Every atom was being called home to a single central point. You can imagine the feeling of being drawn toward a warm, peaceful center, a steady, inevitable pull that requires No effort at all, only the willingness to let go and follow the flow. As this vast, cold sphere began to shrink, something remarkable happened. It began to rotate. In the beginning, the movement was so slow it would have been impossible to see. But as the cloud pulled its mass inward, the laws of physics dictated that it must spin faster. This is a principle we see even today on Earth. Imagine a figure skater on a sheet of perfectly smooth ice. When they start a spin with their arms outstretched, they move slowly, almost lazily. But the moment they pull their arms in close to their chest, they begin to whirl, gaining speed from the very act of becoming smaller and more compact. Our solar system was doing exactly this, pulling its vast cold arms inward and finding its first sense of rhythm. Take a slow, deep breath now and let your own rhythm settle. Just as the cloud found its center, let yourself find yours. Feel the weight of your body, supported and held, much like the particles of the nebula were held by the gentle, persistent pull of gravity. There is no rush. The universe takes its time, moving in cycles that span millions of years, and you can afford this moment to simply be still. The cloud was changing shape. It was no longer a quivering, irregular ghost of gas drifting aimlessly through the dark. The faster it spun, the more the forces of motion began to act upon it. The top and the bottom of the cloud, the poles, started to flatten, while the middle began to bulge outward. It was the beginning of a magnificent transformation, the slow, steady transition from a giant, three-dimensional sphere into a delicate, rotating disk. The chaos of the early nebula was being organized into a structured circle of light and shadow, preparing the way for the sun to wake and for the planets to find their paths. The ancient spherical silence was giving way to the steady, rhythmic pulse of a disk in motion. Imagine the nebula now, no longer a puffy cloud, but a vast, shimmering plate of dust and gas. This is the protoplanetary disk, the silent, pitting nursery where all the worlds are born. As it continues to rotate, the forces of nature are at work, pulling and stretching the material until it is incredibly thin compared to its immense width. It is a moment of profound organization in the history of our corner of the universe. What was once a scattered, drifting mist is now a disciplined, rotating circle, all moving in the same direction, governed by the invisible hand of angular momentum. You can almost feel the steady, rhythmic hum of this great disk as it glides through the dark, a giant wheel of potential waiting to be shaped. It is humbling to realize how much of the universe's story is written in the simple balance of numbers. As the disk flattened and became more compact, the gravity at the center became an irresistible magnet. It pulled in nearly everything that was available, roughly 99.8% of all the material in that original cloud gathered in the dense, crowded heart of the disk. It was a massive accumulation of hydrogen and helium, a heavy growing core that would eventually dominate everything around it. Only a tiny fraction, a mere 0.2% of the mass, was left to drift in the outer rings of the disk. And yet, that tiny sliver of matter, that 0.2%, is responsible for every mountain you have ever climbed, every ocean you have ever seen, and every breath you have ever taken. It is the raw material for the entire family of planets, the moons, the asteroids, and the comets. We are all made of the leftovers, the beautiful remnants of a process that gave almost everything to the center. Because this disk was so flat, the planets that would eventually form within it were destined to stay on that same level path. This plane, which astronomers call the ecliptic, acts like a great invisible floor in space. Even now, as you lie there in the quiet of your room, the planets are all orbiting the sun on this same flat track, like marbles rolling around the rim of a giant shallow bowl. It is why, when we look at the planets through a telescope, they all seem to follow the same narrow highway across the stars. It is why the solar system feels so orderly, so balanced, and so remarkably stable. As the disk continued to spin and the center grew more crowded, the atmosphere within the nebula began to change. The particles at the very heart were no longer just drifting near one another. They were being squeezed together by the immense weight of the material above them. They were bumping into one another with increasing frequency, and with every collision, a tiny bit of energy was released. A deep internal warmth was beginning to stir in the darkness. The center of the disk, once as cold as the void of deep space, was starting to glow with the first embers of a fire that would one day light up the entire sky. The absolute cold of the ancient cloud was fading, and the era of heat and light was about to begin. As the immense weight of the gas and dust pressed inward, the center of our young solar system began to undergo a profound transformation. It was no longer a silent, cold place. Instead, the friction of billions upon billions of atoms rubbing against one another created a new kind of energy. If you could have been there, watching from a safe, quiet distance, you would have seen a faint, deep red glow beginning to pulse in the heart of the darkness. It wasn't the brilliant white gold light we know today, but rather a soft, heavy heat, like the glowing embers of a wood fire late at night. Take a moment now to imagine that warmth. It is a gentle, radiating heat that starts at a single point and begins to push back against the ancient cold of the void. This infant sun, in its very first stage of life, is what astronomers call a protostar. It is a star in the making, a celestial body that is gathering its strength and its mass before it truly begins to shine. It is a period of transition, a bridge between the ghost-like cloud of the nebula and the powerful star that will one day sustain life. At this early stage, the protostar wasn't yet burning in the way we usually think of stars. There were no nuclear reactions happening in its core just yet. Instead, all of that rising temperature was coming from a process called gravitational compression. Imagine the gravity of the entire nebula pressing down on the center, squeezing the hydrogen and helium gas so tightly that the atoms began to vibrate with intense energy. It is a slow, steady buildup of pressure, a gathering of power that happens over hundreds of thousands of years. As you breathe in slowly and let the air out, think of that steady, rhythmic squeezing, a cosmic pressure that is patient, constant, and inevitable. Even as this central fire grew hotter and the red glow deepened, the young sun remained a secret to the rest of the galaxy. Protostars are almost always surrounded by thick, heavy cocoons of dust and gas. These cocoons act like a deep, dark blanket, hiding the growing star from the rest of the universe. To an outside observer, it might have looked like nothing more than a dark, opaque smudge against the stars. But inside that protective shell, the heat was reaching a tipping point. The cocoon was a nursery, keeping the heat trapped and allowing the pressure to mount until the center became almost unimaginably dense. The darkness of the nebula was now holding a great treasure. The temperature at the heart of the protostar was climbing from thousands of degrees to millions. The soft red glow was shifting, becoming more intense, more vibrant. The center was becoming a pressurized furnace, waiting for the spark that would change everything. The long, slow era of the pre-sun was nearing its end. Soon, the pressure would become so great that the very nature of matter would change, and the first true light of our solar system would finally break through its dusty veil, washing over the spinning disk and announcing the birth of a star. As you settle deeper into your pillows, imagine that the long, dark wait of the nebula is finally coming to an end. The pressure at the center of the protostar has reached a point of no return. It is a moment of profound transformation, a transition from a gathering of dust into a source of eternal light. This is the moment of nuclear ignition, the true birth of our sun. For this to happen, the conditions had to be exactly right. The temperature at the very core of the growing star had to climb until it reached a staggering 15 million degrees Celsius. At this unimaginable heat, the very building blocks of the universe begin to change. This is where nuclear fusion begins, the process that powers every star you see in the night sky. In the heart of our sun, hydrogen atoms, the simplest and most abundant elements, are pressed together with such immense force that they fuse together to become helium. This act of fusion is not a sudden, jagged event, but a steady, rhythmic release of pure energy. It is a glow that starts deep within and begins to work its way outward, traveling through layers of dense plasma for thousands of years before it finally reaches the surface. When that first true sunlight finally broke through the dusty cocoon that had hidden the sun for so long, it was like a silent bell ringing across the void. The darkness was pushed back, and the era of the nebula was gone forever. The solar system was no longer a cold cloud. It was a kingdom of light. As the sun began to shine, it also began to breathe. A constant stream of energy and charged particles, known as the solar wind, started to flow outward in every direction. You might imagine it as a soft, invisible tide moving through the shining disk of debris. This solar wind acted as a cosmic gardener, clearing out the neighborhood. It was strong enough to push the lightest, most delicate materials, the vast clouds of hydrogen and helium gas, away from the center of the solar system. This gentle but persistent pressure is the reason our solar system looks the way it does today. Near the sun, where the wind was most direct and the heat was most intense, only the heavy, solid materials could remain. The tiny grains of rock and metal were too heavy to be blown away, staying close to the warmth of the new star. Further out, in the colder depths, where the wind began to lose its strength, the lighter gases could settle and gather in enormous quantities. This invisible sorting process ensured that the inner circle of the solar system would be reserved for the rocky worlds, while the outer reaches would become the home of the gas giants. Take a slow, deep breath and feel the stability of that arrangement. The sun is now a steady anchor, holding everything in its place with its light and its gravity. The chaos of the early cloud has been replaced by a new order, a balance between the heat of the center and the cold of the edges. The stage is now set for the solid ground beneath our feet to begin its long, slow journey of formation, beginning with a boundary where the very nature of matter changes from fire to ice. As the sun's warmth radiated outward, it created a gradient of temperature that would define the destiny of every planet. Imagine, if you will, an invisible boundary stretching across the spinning disk of the early solar system. This is what scientists call the frost line, or sometimes the snow line. It was a silent, invisible threshold where the character of the universe shifted, a line drawn between the searing heat of the inner circle and the deep, biting cold of the outer reaches. Inside this frost line, the environment was intense and unforgiving. The young sun was a powerful source of heat, baking the space immediately around it. In this inner zone, it was simply too hot for volatile substances like water, methane, or ammonia to exist as solids. They couldn't settle. They couldn't freeze. Instead, they remained as invisible vapors, ghosts of molecules drifting in the solar wind, pushed further and further out. If a snowflake had tried to form here, it would have vanished instantly, turning into a wisp of gas before it could even catch the light. Because of this intense heat, the only materials that could remain solid in the inner solar system were those with incredibly high melting points. We are talking about metals and silicates, what we commonly know as rock. These sturdy materials were the only things tough enough to withstand the sun's close embrace. They didn't melt away into gas. They stayed as tiny, shimmering grains of dust, orbiting steadily in the warmth. This is the fundamental reason why the planets closest to the sun, Mercury, Venus, Earth, and Mars, are made of heavy stone and iron. They were forged in the fire of the inner disk, built from the only materials that could survive the heat. This frost line wasn't just a small area near the sun. It was located much further out than you might expect, roughly where the asteroid belt sits today, in the wide gap between the orbits of Mars and Jupiter. It served as a cosmic gatekeeper. Beyond this line, the temperature dropped low enough for water to finally freeze into solid ice. In those distant, shadowed regions, there was much more solid material available because ice was so much more abundant in the universe than rock. This allowed the outer planets to grow into the massive giants we see today, as they had mountains of ice to build with. But for now, let your mind drift back toward the center. Let us leave the frozen darkness of the outer rim for a moment and return to the golden, hazy glow of the inner solar system. Here, the space is filled with a fine, warm mist of rocky dust and metallic specks. It is a quiet, crowded place where the heat of the sun keeps everything in a state of potential. In this inner circle, the story of our own world begins to take shape. There are no oceans yet, no atmosphere to breathe, just a vast, rotating ring of warm debris. It is a landscape of microscopic possibilities where every grain of dust is a building block for something much larger. Feel the gentle warmth of this ancient space, the way the light reflects off the jagged edges of a billion tiny stones. We are focusing our attention here In the cradle of the rocky planets, where the silence is about to be broken by the very first steps of physical construction, the dust is no longer just drifting, it is starting to find its way together. In the quiet of this early disk, a remarkable transformation began to take place. It was a change that started at the smallest scale imaginable. If you could zoom in until a single grain of dust looked as large as a mountain, you would see that these tiny specks were not just drifting past one another. They were beginning to touch. They were beginning to hold on. In these early moments, gravity was still a distant, sleeping giant. These microscopic grains were far too small to pull each other in with gravitational force. Instead, they relied on a much more delicate form of attraction. You might think of it as the cosmic version of the static electricity that makes a balloon stick to a wall, or the way dust bunnies gather in the quiet corners of a room. At this molecular level, a phenomenon known as van der Waals forces came into play. These are weak, short-range attractions between atoms and molecules that act like a very faint, invisible glue. Because of these forces, when two tiny grains of silicate or metal drifted into one another, they didn't simply bounce away, they stuck. They clung to each other in the darkness, forming tiny, fragile chains and clusters. Take a slow, deep breath and imagine these microscopic structures drifting through the warm, golden haze of the inner nebula. There is no wind here, only the steady, rhythmic flow of the rotating disk. As these clusters of dust continued to orbit the young sun, they acted like tiny nets, sweeping up more and more particles. Slowly, almost imperceptibly, these tiny clumps began to grow. What started as microscopic specks became grains of sand. For thousands of years, those grains of sand gathered into pebbles. These pebbles were not smooth like the ones you might find in a riverbed. They were jagged and porous, full of holes and delicate edges that made it even easier for them to snag on passing neighbors. The pebbles eventually found one another, building into rocks the size of a fist, then boulders the size of a house. This grand, slow-motion construction project is what scientists call accretion. It is the process of growth by the gradual accumulation of additional layers or matter. It is a word that sounds like a slow heartbeat. Accretion, the steady, patient building of a world from almost nothing. In the beginning, it was a gentle process, a soft clumping of shadows in the light of the protostar. But as these objects grew larger, the nature of their interaction began to change. The space was becoming more crowded and the movements more complex. It became a cosmic ballet, though one performed in slow motion across vast distances. These boulders were no longer just drifting, they were following paths that frequently crossed. The collisions were not yet the violent, cataclysmic impacts of a later age. Instead, they were more like soft touches, two massive travelers meeting in the dark and deciding to move forward as one. Each merger made the resulting object slightly heavier, slightly more influential. The silence of the nebula was now filled with the subtle, rhythmic pulse of these growing bodies, each one a tiny island of solidity in a sea of dust. We are watching the transition from a cloud of mist into a kingdom of stone, where every small union brings the solar system one step closer to the familiar shapes we know today. The dust has found its purpose, and the stage is being set for the first true architects of the inner circle to emerge from the haze. As the boulders grew, they began to exert a different kind of presence in the disk. They crossed a threshold of size and scale, becoming what astronomers call planetesimals. Imagine, if you can, a world that is not yet a planet, but far more than a simple rock. These were the first small worlds of our system, some the size of a single mountain, others as vast as a small moon, drifting through the thinning curtains of gas and dust. In these early days, the inner solar system was a much more crowded place than it is now. There were once hundreds of these planetesimals, all jostling for space in the warm region near the sun. If you could look down upon the system at this time, you wouldn't see the clear, empty paths we have today. Instead, you would see a swirling swarm of dark, rocky bodies, each one following its own unique journey through the void. It was a time of transition, where the dust had finished its work of gathering, and the first true structures of the solar system were beginning to assert themselves. These planetesimals were the essential seeds for the planets we know today. Every mountain you have ever climbed, every valley you have ever seen, and every grain of sand on a modern beach began as a part of these ancient wandering stones. They were the raw materials of creation, the building blocks that would eventually be forged into the Earth, Mars, Venus, and Mercury. They were like the scattered pieces of a great puzzle, waiting for time and gravity to bring them together into something much larger, something more permanent. The environment they inhabited was one of beautiful, slow-motion instability. Their orbits were not yet the steady, predictable circles of the modern era. Instead, they were slightly eccentric, wobbling and weaving through the disk as they responded to the gravitational tugs of their neighbors. Because there were so many of them in such a relatively small space, their paths frequently crossed. This wasn't a sign of failure in the system, but rather the mechanism of its growth. When two planetesimals met, it was rarely a violent explosion. Because they were often traveling in similar directions at similar speeds, their encounters were more like gentle, persistent tugs. They would drift toward one another, caught in a mutual embrace of gravity, and slowly merge. These mergers were the primary way that the solar system grew. Two mountains would become a range, two ranges would become a small moon. Take a quiet moment to visualize this silent, dark ballet. There is no sound in the vacuum, only the visual majesty of these massive shapes drawing closer and closer until they touch. There is a sense of inevitability in their movement, a slow, patient accumulation of mass. With every merger, the number of objects in the inner solar system decreased, but the size and influence of the survivors grew. The seeds were beginning to sprout, and the hundreds of wandering rocks were slowly being whittled down. Out of the hundreds of small worlds, the foundations were being laid for the emergence of the four inner giants that would one day rule the rocky domain closest to the light. The chaos of the swarm was slowly, patiently finding its order as the largest among them began to claim the space as their own. In the quiet of the cooling disk, the nature of the journey had changed. The small, drifting stones of the previous era had found one another, and in their joining, they had created something entirely new. We move now from the age of the wandering rock to the era of the protoplanet, the true ancestors of the spheres we recognize today. This transition marks a pivotal moment in the biography of our solar system, the moment when gravity ceases to be a subtle influence and becomes the dominant, unyielding master of the domain. A protoplanet is distinguished by its sheer presence. It is no longer a mere passenger in the disk. It is an architect. By definition, a protoplanet is large enough to possess its own significant gravity. This isn't just a slight attraction. It is a powerful, invisible command. Anything that drifts within its reach is destined to become a part of it. This gravity acts like a wide, silent net, reaching out through the vacuum to sweep up the remaining dust, pebbles, and smaller planetesimals that share its orbital path. Gradually, the space around these growing worlds began to clear, creating wide, empty lanes where once there had been a crowded fog of debris. As these bodies grew, they underwent a beautiful physical transformation. You may have noticed that while small asteroids can look like jagged shards or lumpy potatoes, the planets are almost perfectly round. This is the work of gravity's patient hands. Once a protoplanet reaches a certain size, its own internal weight becomes so massive that the solid rock can no longer hold its shape against the constant pull toward the center. Gravity tugs at every mountain and every ridge, dragging them down, smoothing them out, and pulling the entire mass into a sphere. It is the shape of total balance, the shape of a world that has finally come into its own. Take a slow, deep breath and imagine that transition from a jagged, irregular fragment to a smooth, graceful orb revolving in the dark. Yet, these spheres were not yet the solid, quiet places we might imagine. They were born from the energy of countless impacts, and that energy had to go somewhere. Every time a wandering rock struck the surface of a protoplanet, it released a tremendous burst of heat. Because these collisions were so frequent and so powerful, the early planets did not have time to cool down. Instead, the heat built up until the entire body softened. This process kept the early planets in a completely molten state. Visualize, if you can, a world made entirely of liquid rock. There was no solid ground to stand on, only a vast, glowing ocean of magma that rippled and pulsed under the dark sky. These were worlds of light and heat, shimmering with oranges and deep reds, radiating a dull warmth into the cold void. This molten state was essential, for it allowed the materials within the planet to move and shift, settling into the layers that would eventually define their character. Slowly, the violent era of growth began to taper off. The paths were becoming clearer, and the collisions were becoming fewer. The hundreds of small competing worlds had been whittled down by the gravity of the largest survivors. The chaos was subsiding, leaving behind a much lonelier, more organized inner solar system. Out of the original swarm, only 4 great rocky survivors remained to claim the space closest to the sun. They were the victors of a multi-million-year struggle for mass, and they were now ready to begin their long, slow cooling. Each of these 4 would go on to develop its own unique personality, starting with the small, resilient world that clings closest to the light of the sun. As the dust settled and the 4 rocky worlds took their places, we find ourselves looking first at the world that stands nearest to the fires of the sun. This is Mercury, the iron messenger, a world that has endured the sun's intense gaze for billions of years. Imagine the view from its surface where the sun appears massive and overwhelming, casting long, sharp shadows across a landscape of gray dust and ancient craters. Take a slow, deep breath and feel the stillness of this scorched, lonely place. Mercury is a diminutive world, a tiny sentinel in the solar system's inner sanctum. It is, in fact, the smallest planet in our entire solar system. To give you a sense of its scale, it is only slightly larger than our own moon. If you were to place it beside the Earth, it would look like a small marble resting next to a large, heavy grapefruit. It is a world that feels intimate in its size, yet it is shaped by forces of incredible magnitude. But do not let its modest size deceive you. Mercury is a surprisingly heavy world, packed with an unexpected weight that speaks of a complex and perhaps violent birth. Even though it is so small, it is nearly as dense as the Earth itself. This high density is a clue to a hidden history, a secret buried deep beneath its scorched and battered surface. While other planets are composed of thick layers of rock, Mercury is a world dominated by metal. When we peer into the heart of Mercury, we find something truly extraordinary. Most rocky planets are like a fruit with a small pit, but Mercury is almost all pit. It possesses a massive iron core that takes up a staggering 85% of the planet's radius. To visualize this, imagine a giant, heavy ball of iron and nickel wrapped in only a very thin, delicate rind of dark rock. It is as if the planet is a great metallic heart, beating slowly in the silence of the inner solar system, protected by only the thinnest layer of stone. Life on Mercury is a study in stillness and extremes. Because it lacks a substantial atmosphere to trap heat or move air, there is no wind to whistle through its craters and no clouds to soften the sun's glare. During the long Mercury day, the surface is baked in a furnace of light. But as the sun finally sets, the heat vanishes instantly into the vacuum of space, leaving the ground to turn brittle and cold in the deep starry blackness. It is a world of absolute silence, a place where the passage of time is marked only by the shifting of shadows. We leave this small, resilient messenger behind now, drifting slowly outward into the cool dark. As the sun's silhouette grows slightly smaller behind us, we look ahead to a world that appears like a brilliant, steady jewel in the velvet skin. This neighbor is different, shrouded in mystery and hidden beneath a thick, impenetrable blanket of clouds. We are moving toward the brightest planet in our heavens, a world that was once thought to be a twin to our own. Let yourself drift toward that soft golden light as we approach the veiled world of Venus. As we arrive at the threshold of Venus, the harsh, cratered landscape of Mercury fades into a memory. Before us lies a world completely different in character, a planet wrapped in a thick, perpetual embrace of opaque, yellowish-white clouds. In the early days of astronomy, we could not see through this veil. We could only imagine what lay beneath. Because of its brilliance in our night sky and its similar proportions, we gave it a name that suggests a deep kinship, the twin of Earth. Fact. 32. Venus is almost the exact same size and mass as our home world. It is only about 5% smaller in diameter, and its gravity would feel nearly identical to what you feel right now, resting comfortably in your bed. For a long time, because of these similarities, scientists dreamed of a lush, tropical world hidden beneath those clouds, perhaps filled with steaming jungles and vast oceans, mirroring the life we find on Earth. It was a mirror held up to our own world, shrouded in a mystery that we were eager to solve, a sister world that shared our origin. But as we look closer, we find a world that moves to a very different, almost hypnotic rhythm. Most planets in our solar system spin in the same direction, a legacy of the original swirl of the solar nebula. But Venus is a quiet rebel in the celestial dance. Fact 33. It rotates in the opposite direction of most other planets, a motion known as retrograde rotation. If you could stand on its surface and peer through the heavy, heavy haze, you would see the sun rise in the west and set in the east. It is a slow backwards rotation, perhaps the result of a massive collision billions of years ago that knocked the planet off its original course, or perhaps the result of the thick, viscous atmosphere dragging against the rocky surface over eons, eventually slowing the planet down and turning its spin around. This rotation is not just backward, it is incredibly, almost unimaginably slow. Fact 34. A single day on Venus, the time it takes to rotate once on its axis, is actually longer than its entire year. It takes about 243 Earth days to complete one single rotation, yet it only takes 225 Earth days to complete its orbit around the Sun. Imagine the stillness of such a world, where the sun lingers in the sky for months at a time, where the passage of day and night is a process so gradual it is almost imperceptible. It is a planet of profound, heavy patience, a world where time seems to stretch and fold in the silence. As we drift away from this beautiful but stifling world, we look back one last time at its golden, reflective clouds. It is a world that reminds us how delicate the balance of a planet can be, and how small changes in history can lead to vastly different destinies. Now, we turn our gaze toward a point of light that feels familiar, welcoming, and deeply peaceful. It is a blue and white marble, hanging in the velvet darkness, a sanctuary of liquid water and life. We are heading home, settling our attention onto the world we know best, the third stone from the sun. As we approach this blue sanctuary, you might notice how the harsh, yellow glare of the inner solar system begins to soften into a soothing palette of sapphire, teal, and brilliant white. This is Earth. It sits in a very special region of space, a narrow band of orbit that astronomers often call the habitable zone, or more affectionately, the Goldilocks zone. It is the perfect distance from the warmth of the sun. If we were just a little closer, like Venus, our oceans would boil away into a thick, suffocating fog. If we were just a little further out, the water would lock away into eternal ice. But here, in this gentle middle ground, the temperature is just right for the miracle of fluidity. Take a slow breath, feeling the weight of your body against the mattress, much like the weight of the oceans pressing softly against the seabed. Fact 35. Earth is the only planet we have ever discovered that has stable bodies of liquid water on its surface. While other worlds have ice or perhaps hidden underground lakes, only here does the water flow freely in the open air, carving rivers through valleys and filling vast basins that reflect the sky. This water is the lifeblood of our world, a constant, circulating rhythm that regulates the climate and cradles every living thing in a cool, wet embrace. It is a world that breathes through its tides, its clouds, and its rains. Beneath those vast oceans and the continents we call home, there is a hidden strength and a solid foundation. Fact 36. Earth is actually the densest planet in the entire solar system. Even though the gas giants are vastly larger, Earth is more tightly packed with heavy materials. Deep inside a massive core of iron and nickel creates a powerful gravitational pull, holding everything together in a firm, steady grip. This density is a testament to the intense heat and pressure of the early solar system, where the heaviest elements sank to the center to form a solid, reliable heart for the world above. This spinning heavy core does more than just provide gravity. It creates a silent, invisible guardian that watches over us while we sleep. Fact 37. Earth possesses a powerful magnetic field that acts as a protective shield for the entire planet. As the liquid outer core swirls deep beneath our feet, it generates a magnetic cocoon that extends far out into space. This shield deflects the solar wind, a constant stream of charged particles from the sun that would otherwise strip away our atmosphere and bathe the surface in harsh radiation. It is because of this invisible embrace that our air remains thick and breathable, and our skies stay a soft, comforting blue. We are tucked away in a safe, quiet pocket of the cosmos, protected by forces we cannot see, but can always feel in the stability of our environment. As we linger here for a moment, watching the white clouds drift lazily over the deep blue oceans, we feel a profound sense of peace. It is a world of perfect balance, but the journey continues, and our eyes are drawn further out, past the orbit of our home, toward a speck of rust-colored light in the distance. The vibrant blues of Earth begin to fade as we look toward the red horizon of our next neighbor, a smaller, quieter world that tells a story of a different path, and a landscape that has grown still and dusty over the eons. The deep, vibrant blues of our home world slowly recede behind us as we drift further into the quiet dark, moving toward the last of the 4 rocky worlds. Here, the light of the sun feels a little thinner, a little more distant, as we approach a world that feels more delicate and solitary than our own. This is Mars, the red planet, a place of immense silence and ancient dusty plains. As we draw closer, its unique character becomes clear, revealing a world that has grown cold and still over billions of years. Fact 38. Mars is a world of modest proportions, measuring only about half the size of Earth. If Earth were the size of a nickel, Mars would be about as large as a marble. Because it is smaller, it has much less mass, which means its gravity is much weaker, only about 38% of what you feel right now. If you were to stand on its surface, you would feel light, almost as if you were walking through a dream, your steps slow and effortless. This smaller size played a crucial role in how the planet evolved, allowing it to cool much faster than its larger siblings and leading it toward a quiet, frozen maturity. As we look down at the vast rolling deserts, the most striking feature is the color. It is a world of deep oranges, burnt sienna, and dusty reds. Fact 30 nights. This iconic red color comes from the presence of iron oxide in the soil, the very same substance we know on Earth as rust. Long ago, the iron in the Martian rocks reacted with trace amounts of oxygen and water, creating a fine layer of rusted dust that has been blown across the entire planet by ancient winds. Mars is, in a very literal sense, a rusting world, a testament to a time when its chemistry was more active, now settled into a permanent, colorful stillness. Even in this quiet state, Mars holds remnants of a much more powerful past. Fact 40. Mars is home to Olympus Mons, the largest volcano in the entire solar system. To imagine its scale, you must picture a mountain 3 times the height of Mount Everest, with a base so wide it would cover the entire state of Arizona or the country of France. It is a shield volcano, sloping gently upward toward the stars, a silent monument to the massive internal heat that once flowed within the planet. It hasn't erupted for many millions of years, standing now as a grand sleeping giant under a thin, pinkish sky. As we linger in the orbit of this rusting desert, we find ourselves at the edge of the inner solar system. Mars marks the end of the rocky zone, the final frontier before the vast, cold emptiness that leads to the gas giants. We can look back now and see the 4 sisters, Mercury, Venus, Earth, as in each unique, yet each born from the same spinning disk of dust and light. They share a common heritage, a history of heat, gravity, and transformation. But before these worlds could settle into the stable paths they follow today, they had to survive a much more turbulent era. The relative peace we see now was preceded by a time of great chaos, a period when the very heavens seemed to fall, shaping the faces of these worlds in ways we can still see when we look up at the night sky. As we drift away from the red dust of Mars, we begin to realize that the order we see today was not always so certain. The calm, predictable paths the planets now follow were earned through a long and tumultuous youth. Take a slow, deep breath and imagine the solar system as it was nearly 4 billion years ago. It was not yet the clean, empty space we know. It was still crowded with the remnants of the great disk, the leftover scraps of world building that had not yet found a home. Fact 41. For hundreds of millions of years, a period known as the Late Heavy Bombardment occurred, during which the inner planets were relentlessly pelted by this leftover debris. It was a time of heavy rain from the sky, but instead of water, it was a rain of stone, metal, and ice. Imagine billions of boulders, some the size of small hills and others the size of entire cities, drifting through the dark, drawn in by the growing gravity of the young planets. These were the final echoes of the solar system's formation, a chaotic period where the neighborhood was being swept clean by the very worlds that inhabited it. When you look up at the night sky and see the familiar face of the moon, you are looking at a fossil of this era. Fact 42. The dark, smooth patches you see on the lunar surface, often called seas or maria, were created during this epoch of intense impacts. These were not caused by small stones, but by massive objects that struck the moon with such force they cracked its early crust. This allowed molten rock from deep inside the moon to well up and fill the giant basins, cooling into the dark, flat basaltic plains we recognize today. They are not oceans of water, but frozen oceans of ancient lava, silent memories of a time when the heavens were filled with falling fire. While this era may sound like a time of pure destruction, it was also a time of vital delivery. Factor 43. These impacts are believed to have brought essential chemicals and perhaps a significant portion of the water that now fills Earth's oceans. Many of the objects striking the early Earth were comets and asteroids from the colder outer reaches of the solar system, rich in ice and organic molecules. As they vanished into the surface of our world, they deposited the very ingredients that would one day allow life to stir in the deep. What seemed like a period of chaos was, in many ways, a period of sowing seeds. The inner planets were being tempered like iron in a forge as they settled into their final forms. Every crater on Mercury, every scar on Mars, and every drop of water on Earth tells a story of this ancient reign. But among all the collisions that occurred during these long millions of years, one stands out above all the rest. It was not a mere impact of a wandering rock, but a meeting of two worlds, a massive, transformative encounter that would change the destiny of the Earth forever and give us the silver light that guides our nights. As the early solar system moved through its chaotic youth, the most profound moment in our planet's history was about to unfold. We often think of the planets as always having been the solitary giants they are today. But in those first few 100 million years, the space around Earth was shared. Fact 44. Leading scientific theory, known as the giant impact hypothesis, suggests that a Mars-sized protoplanet named Theia was once a neighbor to the early Earth. For a long time, these two worlds shared a similar orbit, drifting through the dark in a slow gravitational dance. But eventually, their paths crossed in a way that would change both forever. It is believed that about 4.5 billion years ago, Theia struck the proto-Earth. It was not a direct head-on collision that would have pulverized both worlds into dust, but rather a glancing blow, a massive, transformative meeting of two celestial bodies. Imagine the scale of this event. Two glowing, molten worlds merging in the silence of the void. The energy released was beyond anything we can truly comprehend, yet in the vastness of space, it was just another step in the long process of creation. The impact was so powerful that it sheared off a significant portion of Earth's outer crust and mantle, while Theia itself was almost entirely destroyed. Fact 45. The resulting debris, a mix of Earth's outer layers and the remains of Theia, was flung into orbit around our world. For a period of time, the Earth was not alone. It was likely surrounded by a thick, glowing ring of vaporized rock and molten fragments, much like the rings we see around Saturn today. Over a relatively short period, perhaps only a few thousand years, gravity began to pull this ring of debris together. It gathered into a sphere, cooling and hardening as it drifted slightly further away, eventually becoming the moon that lights our night sky. This encounter did more than just give us a moon. It gave our planet its rhythm. Fact 46. The force of the collision with Theia is what tilted the Earth's axis to its current angle of roughly 23.5 degrees. This tilt is the reason we have our seasons. As we orbit the sun, different parts of the planet receive more or less sunlight at different times of the year. Without that ancient violent meeting with Thea, our world might have remained perfectly upright, with no spring flowers or autumn leaves, just a static, unchanging climate from year to year. As the moon settled into its orbit and the debris from the impact was either absorbed or cleared away, a new sense of order began to emerge. The era of giant collisions was drawing to a close, and the inner solar system was beginning to find its permanent shape. The planets were no longer moving through a crowded, dangerous hallway of rocks. They had claimed their paths. But though the skies were becoming quieter, the worlds themselves were far from still. They were still incredibly hot, glowing with the residual energy of their formation and the heat of 1 billion impacts. The surfaces were not yet ground to walk upon, but oceans of liquid fire waiting for the long, slow cooling that would eventually turn them into the solid ground we know. The Earth and its rocky neighbors, Mercury, Venus, and Mars, were not yet the solid, silent worlds we recognize today. They were restless and luminous, glowing with a light that came from within. If you could have looked upon the inner solar system during this ancient time, you would not have seen blue oceans, white clouds, or gray craters. Instead, you would have seen 4 spheres of deep, pulsing red and brilliant orange, hanging like glowing embers in the velvet blackness of space. This was the era of the magma oceans. Fact 47. In these early stages, the rocky planets were almost entirely molten, from their surfaces deep down to their very centers. They were not yet made of solid ground, but were instead vast, churning seas of liquid rock. This liquid state was the result of the immense energy gathered during their formation. Every collision with a wandering asteroid or a stray planetesimal had delivered a fresh surge of heat, and the giant impact that formed our moon had turned the Earth into a world of liquid fire. It is peaceful to imagine these worlds as they were then, slowly rotating, fluid spheres, their surfaces rippling with the heat of their own creation. It wasn't just the external impacts keeping things hot, however. Deep inside the hearts of these young worlds, a quiet, invisible process was at work. Fact 48. Radioactive decay of elements trapped deep inside the planets provided a constant, steady source of internal heat. Elements like uranium and thorium acted as a natural furnace, working from the inside out. This ensured that the planets remained soft and pliable, preventing them from cooling too quickly. Imagine the entire planet as a thick, heavy liquid, glowing with a soft inner warmth that refused to fade. It is a strange, comforting thought to realize that the very ground we walk upon was once as fluid as water, flowing in slow, heavy currents under a dark, star-filled sky. Because the planets were in this liquid state, gravity was able to reorganize them with incredible precision. This was a period of grand planetary scale sorting. Fact 49. In this molten state, the heavy elements, most notably iron and nickel, began to sink slowly toward the center of each planet. At the same time, the lighter materials, such as silicates and oxygen-rich rocks, drifted upward toward the surface. It was a silent, inevitable migration. The heaviest parts of the world were finding their way home to the core, while the lighter parts were rising to form the outer layers. This movement was unhurried and rhythmic. There was no wind yet, and no sound of crashing waves, only the steady, heavy churning of liquid rock as the planets began to settle into their internal layers. The surfaces glowed with a dull, steady light, casting a long red hue into the void. But as the frequency of impacts began to decrease, and the immense heat began to radiate away into the cold vacuum of space, the first signs of a great change began to appear. The intense, fiery youth of the planets was beginning to transition into a long, quiet cooling. The liquid fire was finally starting to still, and the very first hints of a solid world were preparing to emerge from the glow. As the heat of those early collisions began to radiate into the cold dark of space, the internal sorting of the rocky planets reached a quiet, rhythmic conclusion. This process, which scientists call planetary differentiation, is one of the most fundamental chapters in the story of any world. It is the moment a chaotic mixture of materials becomes an organized, layered home. Fact 50. This process is very much like oil and water separating in a glass, or the way cream rises to the top of fresh milk. In the intense heat of the early solar system, the planets were fluid enough for gravity to act as a master organizer. The heaviest materials, driven by their own weight, surrendered to the pull of the center, while the lighter, fluffier rocks drifted toward the surface like bubbles in a slow-moving stream. Imagine the planet not as a solid rock, but as a giant glowing marble of liquid, where every atom is searching for its proper depth. This layering created the three main divisions we still live with today: the core, the mantle, and the crust. At the very center of this arrangement lies the core, the dense, heavy heart of the world. In the case of our own Earth, this heart is particularly complex and beautiful in its design. Fact 51. Earth's core is divided into two distinct parts: a solid inner core and a liquid outer core. Even though the temperatures at the very center are as hot as the surface of the sun, the immense pressure of the entire planet pressing downward keeps that innermost iron and nickel squeezed into a solid ball. Surrounding it, however, the pressure is just slightly lower, allowing the metal to remain in a liquid, flowing state. This liquid outer core is never truly still. It churns and swirls in slow, heavy currents driven by the planet's rotation and the heat rising from within. This movement is more than just a geological curiosity. It is the reason we are here. Tit 52. This specific structure, a liquid metal layer moving around a solid center, is what allows for the creation of a protective magnetic field. This field, known as the magnetosphere, acts like an invisible, soft shield that wraps around the entire Earth. It stretches far out into space, gently deflecting the harsh particles of the solar wind and keeping our atmosphere tucked safely against the surface. It is a quiet, invisible guardian, born from the deep, heavy rhythms of the planet's molten heart. As you breathe in and out, feeling the weight of your own body settling into the mattress, imagine the Earth beneath you doing the same. The heavy iron has found its place at the center. The thick, rocky mantle has wrapped itself around the core like a warm blanket, and the very lightest materials have risen to the very top. The chaos of the early collisions is fading, replaced by a sense of order and stability. The vibrant orange glow of the liquid surface is beginning to dim, turning to a deep dark red as the heat continues to escape into the void. The churning of the surface is slowing down. The ripples are becoming less frequent, and the very first hints of a solid, quiet ground are starting to appear. The era of the liquid oceans of rock is coming to an end, and the first firm foundations of the world are beginning to set. The glowing liquid surface of these young worlds, once a sea of churning fire, was finally beginning to change as the immense heat of their formation radiated away into the cold, dark silence of space. The very top layer of the magma began to stiffen and lose its luster. You might imagine it like the thin skin that forms on a bowl of warm milk as it sits quietly on a table, or the way ice first begins to lace across the surface of a pond in the winter. It was a delicate, fragile process. At first, dark patches of solid rock would appear for a moment, only to be swallowed back up by the orange glow of the liquid below. But as the minutes turned into centuries, and the centuries into millennia, these patches grew larger, more stable, and more permanent. Fact 53. As the surface cooled, a thin lithosphere, or crust, began to form. This was the very first solid ground in the history of the inner solar system. It was the birth of the world as a physical place rather than a ball of light. This lithosphere acted like a protective shell, a thin boundary that separated the turbulent, molten interior from the freezing vacuum of the outside universe. Underneath this shell, the mantle remained hot and soft, but on the outside, the planets were finally developing a face. This early crust was dark and rugged, a landscape of jagged basalt and cooling stone that had never yet felt the touch of a breeze or the weight of a drop of water. The way this crust behaved, however, set the planets on very different paths. Fact 54. On Earth, this crust never became a single frozen shell. Instead, because our planet is large and retained so much internal heat, the crust remained broken into massive floating pieces that we now know as tectonic plates. These plates were constantly in motion, drifting slowly over the softer layers beneath them. In a process that continues to this day, Earth's crust is constantly recycled. New land is born from volcanic ridges, while old, tired rock is pulled back down into the hot depths to be melted and repurposed. It is a slow, rhythmic recycling, a way for the Earth to stay geologically young and active, constantly refreshing its surface over billions of years. But for the smaller rocky worlds, the story was different. Fact 55. On Mars and Mercury, the crust eventually became what scientists call a stagnant lid. Because these planets are smaller, they lost their internal heat much faster than Earth did. Their outer shells cooled and thickened until they became a single, solid, and unbroken dome of rock. There were no plates to shift or slide, and no way for the surface to be pulled back into the interior. On Mars and Mercury, the crust became a permanent mask, a silent record of the ancient past that has remained largely unchanged for billions of years. Even as these first solid crusts hardened and settled, the worlds were far from quiet. Beneath that new, still fragile skin, the planets were still full of trapped energy and restless gases. The pressure from the molten depths was building, looking for any small crack or weak point in the cooling rock to escape. The era of the solid ground had begun, but the interior was preparing to speak. Deep within the darkness of the cooling crust, the first great sighs of the planets were beginning to stir, ready to break through the surface and create the very air we breathe. As the crusts of these young planets hardened, they were not the silent, stagnant places we might imagine today. Instead, they were world-sized pressure cookers, filled with the restless energy of their formation. Deep beneath the newly formed rock, the intense pressure of trapped gases needed a way to escape, and it found its path through every crack, fissure, and volcanic vent. If you could look back through the mists of time, you would see these dark landscapes glowing with lines of fire as the planets began to exhale for the very first time. Fact 56. These early atmospheres were fundamentally different from the air we breathe today. They were heavy, thick, and primitive, composed mostly of carbon dioxide, nitrogen, and immense clouds of water vapor. There was no oxygen to be found in these early skies. That would come much, much later, through the slow work of life. For now, the air was a warm, hazy shroud that wrapped around the cooling stone, trapping the heat of the interior and creating a heavy, humid world of shadows. This grand release of gases from the molten depths has a specific name that scientists use to describe the birth of a planet's sky. Fact 57. This process is called volcanic outgassing. You can think of it as the first breath of a new world. As the thousands of volcanoes across the surface erupted, they didn't just spill lava. They poured out the chemical ingredients for future oceans and skies. On Earth, Venus, and Mars, these gases began to accumulate, held in place by the invisible pull of gravity. They created the very first protective layers against the freezing vacuum of deep space, acting like a thermal blanket for the cooling rock. However, not every planet was able to keep what it exhaled. The ability to hold on to an atmosphere depends on a delicate balance of size and distance from the sun. Fact 58. Mercury, the smallest of the Rocky brothers, was simply too small and too close to the sun to hold on to its early atmosphere. Because Mercury has such low gravity, it couldn't tether the gas molecules tightly enough to its surface. At the same time, the relentless solar wind, the stream of high-energy particles flowing from the sun, effectively stripped the gases away as quickly as the volcanoes could produce them. While the other planets were beginning to wrap themselves in thick blankets of cloud and gas, Mercury remained exposed, a bare and lonely rock standing against the solar fire. This difference in how each world handled its new air would go on to define their destinies for billions of years. Earth would eventually find a perfect balance. Venus would become trapped in a suffocating embrace of heat, and Mars would see its atmosphere slowly thin and fade into a cold desert. But for Mercury, the loss of its air was only the beginning of a much more physical transformation. As the smallest planet continued to lose its internal heat to the silence of space, its very body began to change, shifting and buckling in the dark. As we watch Mercury through the lens of time, we see a world that is undergoing a quiet internal struggle. While the other planets were busy building atmospheres and oceans, Mercury was losing the one thing that kept its structure stable, its internal warmth. To understand why Mercury looks the way it does today, we have to look deep beneath its scarred surface, into the heart of the planet itself. Mercury is unique because it is nearly all core, a massive metallic center that makes up a far larger percentage of its body than Earth's core does for ours. This giant iron heart makes Mercury incredibly heavy for its size, but it also meant that as the planet aged, it experienced a physical change unlike any other world in our neighborhood. Take a slow breath and imagine the silence of that cooling metal. Fact 59. As Mercury's huge iron core cooled over billions of years, it began to contract, and the entire planet actually started to shrink. It is a slow, tectonic tightening, like a piece of fruit drying out in the sun. Because the core is so large, its cooling had a profound effect on the outer layers. As the interior pulled inward, the solid rocky crust on the outside found itself with too much surface area for the shrinking volume underneath. It had nowhere to go but to buckle and break under the immense pressure of its own weight. Imagine the skin of a grape as it begins to age. It doesn't stay smooth, but instead develops deep ridges and folds as the fruit inside loses its moisture. On Mercury, this process was much more grand and permanent. Fact 60. This global contraction created massive, winding cliffs known as lobate scarps. These are not just small cracks in the ground, they are giant thrust faults where one piece of the crust was pushed up and over another as the planet squeezed itself tighter and tighter. These cliffs are the wrinkles on Mercury's face, a map of its long history of cooling and drawing inward. The scale of these features is truly difficult to grasp from our perspective here on Earth. Fact 61. Some of these cliffs are hundreds of miles long and reach heights of over a mile. If you were to stand at the base of one of these scarps, you would see a wall of dark, ancient rock rising straight into the black sky, a monument to the moment the planet's very foundation began to shift. These features tell a story of a world that is physically smaller today than it was when it first formed. A rare example of a planet that has literally folded in on itself in the cold of space. Mercury remains a world of hard lines and silent, shrinking sunken. But as we move further away from the sun, we encounter a world that took a very different path. While Mercury was contracting and losing its air, its sister planet was doing the opposite. We turn our attention now to Venus, a world that didn't just hold on to its atmosphere, but became trapped within it. In the thick, whirling clouds of our nearest neighbor, we find a story of heat and pressure that stands as a stark, fiery contrast to the quiet, shrinking deserts of Mercury. While Mercury is a world defined by its lack of air, Venus is defined by the sheer weight of it. Imagine a thick, heavy blanket of clouds, so dense that they wrap the entire planet in a perpetual golden twilight. It is a world of crushing pressure and strange stillness, where the wind at the surface moves as slowly as water in a deep, dark pond. But Venus was not always this way. It did not begin its life as a furnace. It began as a world of potential, a twin to our own Earth in almost every physical sense. Take a deep, slow breath, and imagined a time billions of years ago when Venus was a very different place. Fact 62. Current research and sophisticated computer simulations suggest that for its first 2 billion years, Venus likely had liquid water oceans and a climate remarkably similar to our own. It may have even been the first truly habitable world in our solar system, with gentle waves lapping against rocky shores under a much younger, dimmer sun. For nearly half of its life, Venus was likely a blue and white marble, a sister world to our own in more than just size and mass. It was a place where life might have found its first foothold long before the Earth had finished its own cooling. However, the stars we orbit are not constant. They change and grow as they age. Fact 63. As the sun grew older, it naturally became brighter and more intense, pouring more energy into the Venusian atmosphere. Because Venus is closer to the sun than Earth, this extra heat began to slowly evaporate those ancient primordial oceans. Water vapor, while essential for life, is also a powerful greenhouse gas. As more water rose into the sky, it trapped more heat, which in turn evaporated more water. This is known as the runaway greenhouse effect, a feedback loop that eventually stripped the planet of its water and replaced its blue skies with a thick, suffocating haze of carbon dioxide. The water was lost to space, and the planet was left to bake in its own trapped energy. The Venus we see today is the final, haunting result of that ancient transformation. Fact 64. The surface of Venus is now a place of extreme hostility, where temperatures remain a constant 900 degrees Fahrenheit, or about 400 to 75 degrees Celsius. This is hot enough to melt lead and turn a solid block of zinc into a shimmering liquid. There are no seasons on Venus and no relief from the heat. The thick atmosphere acts like a thermal reservoir, holding onto the sun's energy with a grip that never loosens, even during the incredibly long Venusian nights. Standing on the surface of Venus would feel like being 3,000 feet beneath the Earth's ocean. The air itself is so heavy, it would resist your every movement, a thick, hot fluid of carbon dioxide. It is a world where the environment has reached a point of absolute fiery stability, a planet that has been cooked by its own success at trapping heat. It is a silent, orange-tinted landscape of volcanic plains and crushed stone, forever hidden beneath its veil of acid clouds. When we look at Venus, we see the profound importance of balance. It is a world that had all the right ingredients: the water, the size, the rocky foundation, but lost its way as the solar system matured. It serves as a stark, sobering contrast to the miracle of our own home. As we move our gaze just a little further from the sun, we find a world that faced similar challenges, but found a different path. While Venus was losing its water to the sky, Earth was beginning to experience a transformation that would turn it into a sanctuary. We turn now to the story of Earth's stability and the moment the first great rains began to fall on a cooling, rocky world. While Venus remained a world of eternal fire, Earth began to find its balance through a transformation that was both powerful and incredibly gentle. The early atmosphere was a thick, heavy blanket of steam, carbon dioxide, and nitrogen. For millions of years, the surface was simply too hot for liquid water to exist. If a drop of rain managed to condense in the upper, cooler layers of the atmosphere, it would begin its long descent, only to be turned back into steam by the rising heat of the crust before it could ever touch the ground. But as the planet continued to radiate its heat away into the dark, a threshold was finally crossed. The surface cooled enough to hold on to the water that the sky was trying to give it. Factor 65. Scientists believe that once the atmosphere reached the right temperature, it may have rained on Earth for thousands of years continuously. Imagine the sound of that era, an endless, rhythmic drumming against the cooling volcanic rock. There was no sun, no moon, and no stars visible through the thick gray clouds that wrapped around the world. It was a time of total immersion, where the sky and the ground were joined by a constant curtain of falling water. This wasn't a storm of destruction, but a long, slow washing of the world, a cooling bath that lasted for centuries upon centuries. Fact 66. As the water fell, it naturally sought the lowest points of the landscape. It carved paths through the cooling lava fields and gathered in the massive, hollowed-out basins left behind by the great impacts of the early solar system. These low-lying areas, some of them thousands of miles wide, slowly filled to the brim, forming the first primordial seas. The Earth was no longer just a dry, rocky orb. It was becoming a world of horizons, where the dark stone met the shimmering, dark water for the first time. The vast, empty plains that once glowed with the heat of creation were now hidden beneath the weight of a new global ocean. Fact 67. This new abundance of water did more than just fill the oceans. It helped regulate the planet's temperature and maintain its stability. Unlike Venus, where the carbon dioxide remained trapped in the atmosphere to bake the surface, Earth's new oceans began to absorb those gases. The rain washed carbon out of the sky and carried it into the sea, where it eventually settled into the crust as carbonate rocks. This process acted like a thermostat, preventing the planet from getting too hot or too cold. It was the beginning of a delicate, beautiful cycle that would keep Earth habitable for billions of years to come. But as Earth found its rhythm in the rain, its smaller neighbor was facing a different kind of ending. Further out in the cold, Mars was also cooling, but its smaller size meant its internal fires were fading much more quickly. We now look toward the red horizon to see how the loss of heat can change the destiny of a world, and why the silence of the Martian deserts is so different from the silence of our own deep seas. While Earth was wrapping itself in a blanket of clouds and rain, Mars was experiencing a much quieter, more somber transition. It had started with similar promise: volcanoes venting gases, water perhaps flowing across its surface in ancient riverbeds. But Mars is a smaller world, and in the vast theater of the cosmos, size often dictates destiny. As the heat of its formation began to radiate away into the cold vacuum, the red planet began to change in ways that would silence its surface forever. Fact 68. Mars cooled significantly faster than Earth because of its smaller size. In physics, smaller objects have a higher surface area to volume ratio, which means they lose their internal heat much more efficiently than larger ones. Think of it like a small cup of tea sitting on a table. It loses its warmth far more quickly than a large, heavy pot of water would. In those early billions of years, while Earth's interior remained a churning, molten engine of activity, The geological fires inside Mars began to dim and fade. The planet was simply too small to hold on to its warmth for long. As the interior of the planet cooled, the rhythmic liquid motion at its center began to stutter. Fact 69. Scientists believe that early Mars possessed a powerful magnetic field, very similar to the one that protects Earth today. This field was generated by a planetary dynamo, the swirling convective motion of molten iron deep within its core. This motion created an invisible shield of magnetic force that reached far out into space, acting as a barrier against the sun. However, as the core cooled and the iron began to solidify or stop circulating, this dynamo slowed down and eventually stopped. The magnetic shield didn't disappear all at once, but rather withered away over millions of years, leaving the planet's atmosphere completely exposed to the elements of the solar system. Without that invisible wall of protection, the planet was left defenseless against a constant, invisible force from the stars. Fact 70. Once the magnetic shield vanished, the solar wind, a relentless stream of high-energy particles flowing outward from the sun, began to strike the Martian atmosphere directly. Without a magnetic field to deflect these particles, the solar wind acted like a slow cosmic sandblaster. Molecule by molecule, the sun's energy stripped the atmosphere away, whisking it off into the dark void of space. The thick, warm air that might have once allowed for liquid oceans was gradually thinned until it could no longer trap heat or provide the pressure needed for water to remain on the surface. The vibrant potential of the red planet slowly evaporated. The rivers dried up, the volcanoes fell silent, and the atmosphere became the thin, cold whisper that we observe today. The silence of the Martian deserts is an ancient, heavy stillness, the quiet of a world that lost its protection long ago and has been buffeted by the solar wind for eons. It is a landscape of frozen history, where the dust settles over canyons that haven't seen a drop of rain in billions of years. As we contemplate the stillness of Mars, we begin to realize that the life of a planet is a delicate dance between its internal heat and the cold of space. The difference between a living world and a silent one often comes down to the simple physics of how much heat a planet can hold. We turn our attention now to the role of size and why some worlds stay active for billions of years while others drift quietly into a long geological sleep. As we consider the silence of the Martian plains, a natural question arises, a question of why. Why did one world flourish with activity while its neighbor grew cold and still? The answer lies in a fundamental principle of the universe, one that governs everything from a cup of warm tea to the massive bodies of the heavens: the role of size. In the quiet of the night, you might notice how a small ember in a fireplace fades to gray in moments, while a thick, heavy log continues to pulse with a deep orange glow for hours. Planets operate on this same simple logic. Fact 71. Larger planets retain their internal heat for much longer than smaller ones. This is due to the relationship between a planet's volume and its surface area. A large world like Earth has a vast interior where heat is trapped, but a relatively small surface area through which that heat can escape into the cold vacuum of space. Like a large baked potato that stays hot long after it has been removed from the oven, Earth and Venus have spent billions of years slowly cooling, while the smaller Mercury and Mars lost their warmth much more rapidly. This internal heat is the heartbeat of a planet, and its presence or absence determines the world's entire destiny. Take a slow, deep breath and imagine that heat trapped deep beneath the ground, miles and miles below the bed where you rest. It is a steady, ancient warmth, left over from the violent collisions of the solar system's birth and maintained by the slow decay of radioactive elements in the rock. Fact 72. This internal heat acts as the engine for a planet, driving the massive, slow-motion processes of plate tectonics and volcanic activity. When a planet is hot inside, its mantle, the layer of rock beneath the crust, is not solid and brittle, but moves with the consistency of thick, warm taffy. This rock rises and sinks in great slow circles, called convection currents. These currents push against the surface, cracking it into plates that slide and collide, and occasionally allowing molten rock to burst through as volcanoes. This process does more than just move mountains. It recycles the planet's crust and releases essential gases that maintain the atmosphere. Without this internal engine, a world becomes geologically dead, a stagnant sphere of cold stone. But for the larger siblings of the inner solar system, the fire still burns. Fact 73. Earth and Venus are the only two inner planets that are still geologically active today. Because of their significant mass and size, they have stayed warm enough to keep their interiors in motion for over 4.5 billion years. On Earth, we see this in the shifting of continents and the eruption of peaks like Mount Etna or the volcanoes of Hawaii. On Venus, though hidden by thick clouds, radar mapping suggests a surface dotted with thousands of volcanoes, some of which may still be pouring fresh lava onto the plains of today. These two worlds have remained alive in a geological sense, their surfaces constantly being reshaped and renewed by the energy lingering in their cores. It is a comforting thought to realize that the ground beneath us is part of a living, breathing system, a world that has the strength to hold on to its warmth against the infinite cold of the dark. While the smaller worlds have settled into a permanent icy sleep, Earth continues its long, slow metabolism. As the internal heat of these planets provides a steady pulse from within, the external world has also found a sense of order. The chaotic era of collisions and flying debris has long since passed, replaced by a profound and predictable clockwork. We move now from the churning interiors of these worlds to the grand, sweeping paths they take through the void, the steady, unwavering rhythm of the orbits that have kept the solar system in balance for eons. Imagine the solar system not as a collection of spinning rocks, but as a grand, silent clock. Every gear, every wheel, and every pendulum has been carefully adjusted over billions of years. This celestial clockwork is governed by gravity, the invisible thread that connects every atom in the universe. In the early days, the planets and moons spun wildly, full of the chaotic energy of their birth. But as the eons passed, gravity acted like a gentle hand on a spinning top, slowing the motion, smoothing the edges, and bringing everything into a beautiful, synchronized rhythm. It is a slow, heavy dance that takes millions of years to perfect, a transition from the frantic to the serene. We see this most clearly when we look up at our own night sky and see the familiar features of our closest neighbor. Fact 74. The moon is tidally locked to the earth, which means it always shows us the exact same face. For billions of years, Earth's gravity has been tugging on the moon, creating what scientists call tidal bulges in its solid rock. This constant stretching and squeezing acted like a soft friction brake, gradually slowing the moon's rotation until it matched the time it takes to orbit our planet. Now, the moon's day and the moon's year are exactly the same length. It is a permanent, silent gaze, a companion that never turns its back, forever keeping its eyes on us as it cradles our world in its reflected glow. Further in, closer to the overwhelming pull of the sun, this gravitational dance becomes even more intricate and disciplined. Fact 75. Mercury, being the planet closest to the sun, was subjected to immense tidal forces that should have eventually stopped its rotation entirely. Instead, because its orbit is not a perfect circle, it found a unique harmony known as a 3-to-2 orbit resonance. This means that for every 2 times Mercury completes a journey around the sun, it rotates on its axis exactly 3 times. It is a precise mathematical balance, a rhythm that allows the planet to survive the sun's intense pull without being completely overcome. If you were to stand on the surface of Mercury, the sun would appear to move strangely across the sky, sometimes slowing down or even appearing to move backward, all because of this perfectly timed celestial choreography. This isn't just a coincidence of physics, it is the inevitable result of a long, patient process of refinement. Fact 76. These rhythms, these perfect ratios of spin and orbit, are dictated by the invisible pull of gravity working over vast stretches of time. Every planet and every moon in our system is slowly being sculpted by these forces. Even Earth's rotation is very gradually slowing down, as the moon's gravity gently pulls on our oceans, lengthening our days by a fraction of a second every century. It is a reminder that nothing in the universe is truly static. Everything is part of a slow unfolding story of balance. The solar system has moved away from the frantic energy of its youth and into a period of majestic, predictable stability. As you settle deeper into your rest, you can almost feel that stability in the air around you. The planets are exactly where they are supposed to be, moving at the speeds they were meant to move, held in the warm, steady embrace of the sun. This order provides a sense of profound peace, a cosmic reassurance that the universe is not a place of chaos, but a place of deep and enduring harmony. The paths are clear, the rhythms are set, and the great silence of space is filled with the steady, rhythmic ticking of this ancient golden clock. This stability has been the foundation for everything that followed, providing a safe and unchanging stage for the next great chapter of the cosmos. At the center of all these orbits, holding every planet in its place with a gentle but firm grip, lies the anchor of our world. After the turbulent era of its birth and the energetic outbursts of its youth, the sun settled into a long, magnificent period of calm. It is currently in a phase of its life that astronomers call the main sequence. You can think of this as the sun's long, steady afternoon, a time of balance where the outward pressure of the energy it creates is perfectly matched by the inward pull of its own gravity. It is neither shrinking nor expanding. It is simply glowing with a constant, dependable light. Fact 77. Astronomers classify our sun as a G-type main sequence star, often referred to by the charming and humble name of a yellow dwarf. While the word dwarf might make it sound small, our sun is actually larger and brighter than about 80% of the stars in our galaxy. Its G-type classification means it is at the perfect temperature to emit the white gold light that we know so well, a light that carries the precise amount of energy needed to stir the chemistry of a planet without overwhelming it. It is a middle-sized star, avoiding the short, violent lives of the massive blue giants and the temperamental, flaring nature of the smaller red dwarfs. It is, in every sense, the perfect guardian for a family of planets. As you lie there, imagine the sun not as a raging furnace, but as a vast glowing reservoir of warmth, pulsing with a slow and steady heartbeat that has not faltered for eons. Fact 78. The sun has been in this incredibly stable state for over 4 billion years. In the grand timeline of the universe, such consistency is a rare and beautiful gift. While other parts of the cosmos have seen stars collide, explode, or fade away, our sun has remained a constant, golden presence. It has processed its hydrogen fuel with remarkable patience, turning matter into light at a rate that ensures it will remain exactly as it is for billions of years to come. This middle age is a time of cosmic maturity, where the wild energies of creation have been channeled into a peaceful, life-sustaining flow. This endurance is the secret ingredient to everything we see around us today. Fact 79. This immense stability provided the billions of years of consistent warmth and light needed for life to slowly emerge, adapt, and eventually thrive on Earth. Life is a delicate process that requires time, vast, unfathomable stretches of time to find its footing. Because the sun did not flicker, because it did not grow too hot or too cold, the oceans of Earth remained liquid and the atmosphere remained steady. We exist because the sun is patient. We are here because our star chose to settle into a quiet, enduring rhythm, providing a safe harbor in the vastness of space. Take a slow, quiet breath now and let yourself appreciate that balance. Feel the weight of your body supported by the earth, and imagine the earth itself supported by the steady pull of that distant, golden light. There is no rush in the heart of the sun. It has all the time in the world to keep watch over us. Everything is in equilibrium. The heat, the light, and the gravity are all working together in a silent, invisible harmony. You are part of a system that has been stable for billions of years, a system that was built to last, allowing you to let go of the day and drift into the same deep, enduring peace that fills the space between the stars. The sun is at rest in its maturity, and you too can find rest in this moment of perfect cosmic stillness. As we move our gaze away from the steady, golden warmth of the sun. We see the inner solar system as it exists today, not as the chaotic storm of fire and rock it once was, but as a place of profound order and deep silence. The long, tumultuous era of planetary birth has come to a gentle pause. The four rocky worlds have finished their growth, their surfaces have cooled, and they have settled into a quiet maturity that mirrors the stability of the star they orbit. Fact 80. The inner solar system is now a very clean place, containing very little debris compared to its early, crowded days. In the beginning, the space between the planets was thick with leftover dust, jagged boulders, and rogue fragments that made every orbit a journey through a minefield. But over billions of years, the gravity of the planets has acted like a cosmic broom. Most of that leftover material has been pulled into the planets themselves, swallowed by the central fire of the sun, or flung out into the cold, distant reaches of the outer system. When you look up at the dark gaps between the stars tonight, that emptiness is a testament to this long process of tidying. The void is clear, open, and peaceful. It is a space that has been swept clean by time. This clarity brings with it a sense of deep cosmic security. The violent era of giant impacts and planetary migrations has faded into the ancient past, leaving behind a neighborhood that is remarkably still. Fact 81. We are living in a period of relative cosmic calm. While the universe is always in a state of flux, the rate of change in our corner of the galaxy has slowed to a soft whisper. For hundreds of millions of years, the arrangement of our solar system has remained virtually unchanged. There are no more planets colliding, no more orbits shifting wildly, no more celestial giants jostling for position. We exist in a long, quiet afternoon of the solar system's life, a golden age of stability. This calm is the foundation of our world. It is what allows the seasons to follow one another predictably, and what allows us to sleep soundly, knowing that the celestial clockwork is moving with a gentle, unwavering precision. Imagine those four rocky worlds now, drifting through that clean, dark space. They are no longer glowing with the heat of their molten youth, but are instead cool and silent, reflecting the soft light of the sun like polished stones in a garden. Fact 82. The planets have finally found their permanent paths around the light. These orbits are the result of a multi-billion-year dance that has finally reached its perfect final rhythm. Each world has carved out its own territory, a specific distance, where the inward pull of the sun and the outward momentum of the planet are in total, effortless balance. They follow these paths with a grace that requires no energy and no struggle. They circle year after year, century after century, in a loop that does not falter. It is a closed circuit of motion, a repetitive, soothing cycle that echoes the rhythm of a slow, deep breath. As you feel the stillness of your own room, try to imagine the stillness of these planetary paths. In the vacuum of space, there is no wind to disturb them and no friction to slow them down. They simply glide. Mercury in its quick, small circle, Venus in its thick, slow-turning orbit, Earth in its vibrant, life-giving loop, and Mars in its quiet red arc. They are all exactly where they are meant to be. They are home. Let this sense of permanence settle over you like a heavy, warm blanket. The chaos of creation is over. The clearing is complete. The paths are set. You are safe within this grand, orderly design. Just as the planets have found their place in the silence of the solar system, you are finding your place in the silence of the night. There is nothing left to do, and there is nowhere else you need to be. The universe has done the long, hard work of settling into place, and now it invites you to do the same. Feel the quiet present surrounding you, a vast and ancient calm that has been billions of years in the making. Everything is steady. Everything is at peace. You are drifting in the same perfect balance that holds the worlds in their tracks. To truly appreciate this stillness, we must look beyond the distance of the planets and consider the vastness of the time they have traveled. Time, on a cosmic scale, moves differently than the seconds we count on a clock. It is deep, wide, and incredibly patient. As you lie there, feeling the weight of your body against the mattress, consider how long the stage was being set for this very moment of rest. Fact 83. If Earth's history were condensed into a single 24-hour day, humans would only appear in the very last second before midnight. For the other 23 hours, 59 minutes, and 59 seconds, the Earth was busy. It was cooling, shifting, breathing, and growing. It was a world of vast, empty oceans, of shifting tectonic plates, and of long, silent eras where the only sound was the wind and the waves. We are the newcomers, tucking ourselves into an ancient, sturdy bed that has been prepared for us over billions of years. There is a profound comfort in this. The world has existed for an unimaginable length of time without our effort, and it will continue to turn quite peacefully while we sleep. You do not need to hold the world together tonight. You can simply exist within its long established history. This sense of time is reflected in the very ground beneath us. We think of cooling as something that happens quickly, like a cup of tea losing its steam on a bedside table. But fact 84, the cooling of a planet takes billions of years. Even now, nearly 5 billion years after its birth, the Earth is still cooling. It is still radiating the heat of its creation out into the cold of space with incredible, slow-motion grace. This internal warmth is what keeps the heart of our planet beating, driving the slow crawl of the continents and the release of volcanic breath. It is a process so slow that it is invisible to us, a steady and deliberate release of energy that happens at a pace we can barely fathom. It is the ultimate expression of cosmic patience. Everything in the universe operates on these grand scales, far beyond the reach of our daily worries. Fact 85. The universe is patient, moving in slow, grand cycles. It does not rush toward a finish line. It does not hurry its processes. The stars burn for billions of years. The planets circle for eons. The galaxies drift through the void over trillions of miles. Everything moves with a heavy, deliberate certainty. There is no urgency in the stars, and there is no haste in the dark spaces between them. When you feel the pressure of the day or the rush of the coming morning, remember this cosmic pace. The universe is not in a hurry, and tonight you don't have to be either. You can let go of the need to move fast. You can let go of the feeling that time is running out. In the grand story of the solar system, time is abundant. It is a vast ocean that we are simply floating upon. Allow your heart rate to slow, matching the long, slow cooling of the earth. Align your own rhythm with the grand, silent cycles of the cosmos. You are part of a very old, very patient story. The night is long, the stars are distant, and there is all the time in the world for you to simply drift, breathe, and rest. Feel the layers of time beneath you, supporting you as you sink deeper into the quiet of the present moment. Everything is moving exactly as it should, in its own at its own perfect, unhurried pace. The light in your room is likely very dim now, a soft reflection of the quiet that has settled over the world. As you lie there, feel the specific warmth of your blankets, a small, cozy pocket of heat that mirrors the internal warmth of the planets we've discussed. Outside, the stars are shining in a silence so profound it seems to vibrate. We often think of the space between those stars as a great empty nothingness, but the universe is rarely truly empty. Fact 86. Space is not a true vacuum. It is filled with a very thin plasma. This solar wind is a stream of charged particles flowing outward from the sun, bathing every planet in a ghostly, invisible mist. You're not floating in a void. You are resting within a vast, subtle atmosphere that spans the entire solar system. You are held by the very breath of the stars. Even the light that defined your day has a journey and a rhythm of its own. Fact 87. The light from the sun takes about 8 minutes to reach your eyes. When you look at the sky, you are always looking back in time, seeing the sun as it was moments ago. There is a beautiful delay in the universe, a refusal to be rushed. This 8-minute journey through the silence of the plasma reminds us that even the fastest thing in existence, light itself, takes its time to arrive. If the light can be patient, then you can be patient too. You can allow your thoughts to slow down, knowing that they do not need to reach their destination tonight. They can simply drift like light traveling through the dark, unhurried, and calm. As your breathing becomes steady and slow, consider the most intimate connection you have with the story of the cosmos. Fact 88. You are made of the same atoms that were in that original nebula. The very same hydrogen, carbon, and oxygen that swirled in that cold, dark cloud 4.6 billion years ago are the building blocks of your body today. The atoms in your left hand might have come from a different dying star than the atoms in your right. You are a collection of ancient stardust, gathered together for a brief moment to experience the wonder of the world. The history of the solar system is not something that happened only out there or long ago. It is something that is happening within you right now. You are the universe resting. You are the ancient nebula dreaming of itself. The journey we have taken tonight, from the first collapse of a gas cloud to the formation of the rocky worlds, is your history. It is a story of gravity, heat, and eventual cooling. And now, it is time for your own cooling, your own quiet settling. The heavy work of the day is over. The planets are in their orbits. The sun is burning steady and bright, and the earth is turning with a rhythmic, reliable grace. There is nothing left for you to do but drift. Feel the weight of your body sinking into the mattress, as if gravity is giving you a gentle, welcoming hug. Let the darkness of the room be a soft blanket, shielding you from the cares of the waking world. The stars will continue their silent watch, and the planets will continue their long, slow dance. Whether you are awake to see them or not, you are safe. You are part of a magnificent, enduring balance. There is a profound peace in knowing that you are a part of this ancient system, a tiny but essential note in a cosmic symphony that has been playing for billions of years. May your dreams be as vast and peaceful as the interstellar clouds, and may your rest be as deep as the core of a silent world. You have traveled across billions of miles and billions of years tonight, and now you have arrived at the most important destination, a place of total, undisturbed rest. Sleep now, knowing you are exactly where you belong in the great shimmering tapestry of the stars. Sleep in the warmth. Sleep in the silence. The universe is at peace, and you are at peace with it. Deep, restorative sleep is yours. Good night and sweet dreams.